Okay, let's do this. All right. Well, good morning, everybody. Hope you're doing well. It's pretty late here, 8 a.m. I think you guys have probably all been up since about 4:35, something like that. So props to you for doing that and getting all your schoolwork done. It's wonderful. Love to hear it. So we get on not yesterday, Monday. So we started off doing the first, just kind of reviewing solving system equations by substitution, solving by elimination, and then we kind of briefly talked about, so like what's on my screen right now is solving the systems with when there's three equations and three variables, and kind of the process that we go through to do that. And we started off with this first example. So really, just as a reminder, it's all about just turning a 3-equation system into a 2-equation system. And then once we have a 2-equation system, just solving it like we normally know how to. Okay. These are the same notes that I sent out from Monday. So if you already had those, or it's the same exact file, we just didn't finish it. So yeah, I will, I guess, go ahead and just kick off the next examples. We're just going to do like 2 examples today and maybe 3. I don't know, probably won't take the full time, but just these problems are kind of long and annoying. So we won't do a ton in terms of notes or problems. We'll just probably do about 2 examples, maybe 3, if we super feel like we love math a ton, which you all do. I know. All right. So let's set up this next system. So I have these 3 equations. I have 3 variables, x, y, and z. And I want to solve for all of them. Okay, we want the full system solution. So our first decision that we have to make is choosing what variable do we want to eliminate first. And this is totally up to you. We can choose x, we can choose y, we can choose z. In our example that we did on Monday, we eliminated z first, just because the second equation didn't even have a z in it, so it already did some of the work for me. That was kind of nice. In this problem, though, I don't have that luxury. There's an x in every equation, there's a y in every equation, there's a z in every equation. So it's up to us. I would say, though, when I look at this, I'm focusing on these 2, because since it's just negative, the coefficients for both these are just -1, -1x, and -1x. It's going to make it pretty easy for me to multiply stuff to find those positive, negative versions of the numbers, so that when I add the equations together, the variable gets eliminated. So again, I'm going to label these just 1, 2, 3, so that I can talk about them more easily. And the first thing I'm going to do is I'm going to take equation 2 and multiply it by -1. All right, so I'm taking the entire equation, multiply it by -1. So that would give me positive x, positive 5y, negative 6z, and positive 24. Right, so every term in the equation, just change signs because it's just multiplying by negative. And then the third equation, I'm just going to leave exactly how it is. I don't need to do anything to the third equation because I've already met my goal of having the two variables that have the same coefficient, just change of sign. So for these x's, coefficient's +1 or -1. So that's great. That's exactly what I want. And again, as a reminder, if you have a question, just alert me really quick in chat. Just say like wait or question or hold on or something. That way I know that I can pause while you take a few seconds to actually type out what the question is, because I know it's harder to type out a question than just raise your hand and say it. And I know you guys love asking questions. See, that's the thing. That's what I love about you guys. See, even now, it's just full of questions everywhere. So keep that up. So now I'm going to go through and add these equations together. Right, just column by column. Everyone is totally up to. I agree. Again, I assume you guys have been up for hours. X plus -x is 0, so I'm not going to write anything there. 5y plus -4y is just y. -6z plus 5z, so minus z. 24 plus -21 is 3. And when I get this equation, I'm going to mark this in some way. Put some stars by it, circle it, do something, because we're going to need to use it later on. But first, we're going to have to do some other stuff. But I want to remember, hey, this was the important equation that I had. So we eliminated x. Now I want to choose different equations to eliminate x again. So we already used 2 and 3, equation 2 and equation 3. So I don't want to use those same two equations because I would just get the same exact result. So I need to choose some other combination. So I can choose 1 and 2, 1 and 3, either way. Okay. It doesn't particularly matter in this case. But let's say, so equation 1 and equation 2, just because that's so exciting. All right, so I'm going to choose equation 1 and equation 2. I might need to do some multiplying by both of them. So first, I'm just going to look at the coefficients. All right, so for equation 1 and 2, for the variable of x, the coefficients are 5 and -1. My goal is to get those to be the same number, just different signs. So the easiest thing to hit here would be just +5 and -5. Especially since equation 1 is already a 5. Equation 2 is already negative there. So all I need to end up doing is just take equation 2 and multiply it by 5. So when I do that, -1 times 5 is -5x. -5 times 5, minus 25y. 5 times 6z, 30z. That's kind of messed up. And -24 times 5, -120. I think that's right. Oh, yeah. So just multiplied all of equation 2 by 5. Equation 1, like I mentioned before, I can just leave that the same. 5x minus 4y plus 2z equals 21. There's no telling in solving these equations will you just need to multiply one of the equations? Will you need to multiply both of the equations? Which one? It just depends on what the numbers are, and it depends on what variables you choose and what your goal number is. So for example, in this part, we chose 5 and -5, just because that was an easy choice to make, because the coefficient of the first equation was already 5. But I might need to choose different numbers depending on what it is. So let's go through and now add these equations together. 5x and -5x is 0. -4y plus -25y is -29y. 2z plus 30z plus 32z. Right? And -120 plus 21, -99. Same thing like I did before. I'm going to star this equation because I need to use it again. Okay, so I've eliminated x in 2 different cases. So now I have these 2 new equations, those red starred ones. That is now my new system. So I'm just going to write those 2 equations down here, just so that they're both together. Just kept them exactly the same. And now I want to just do basically the same thing I just did, but with these 2 equations. So now I want to eliminate y, or eliminate z. We already eliminated x, so now let's eliminate another one. You can choose y or z, totally up to you. Does not matter. You should always still end up at the same answer eventually. You'll have different process, different numbers, but you should still always get there. I'm going to choose, I don't know, doesn't matter. I'm going to choose to eliminate y. So right now I'm looking at the coefficients of y, which is an invisible 1 and a -29. So my kind of least common multiple of those would be 29. All right, so that's my goal that I'm going to reach. So I already have a -29 in the second equation. So let's just make a +29 in the first equation. So I'm going to multiply that entire equation by 29. So that would give me 29y minus 29z equals 87. Now, the worst part about doing this virtually is I can't just rely on you guys to calculate things for me. I have to do things in my head, but then I have to actually check it on my own calculator because I know that you won't tell me if I write the wrong number down. Tough. It's tough. And this second equation, I just kept exactly the same. So now I'll add the 2 equations together. 29y plus -29y, 0. -29z plus 32z, 3z, 87 plus negative 99, negative 12. So now that I've eliminated y, I just have a nice, simple one-step equation, 3z equals negative 12. So I can immediately solve that. Divide 3, z equals negative 4. So that's a good start for me. It took a lot of work to get to z equals negative 4. Now that's a third of my answer that I should have, because I need to know what x equals, I need to know what y equals, and I need to know what z equals. Okay, all of them. So let's work our way backwards. Now that I know z, I can figure out y, because I have two equations here that just have y and z. So if I plug in z to either one of these, I can solve for y. Does not matter which one. Just choose the easiest one and go from there. So y minus z, but instead of z, we know z should be negative 4 equals 3. So that's y plus 4 equals 3. Y equals negative 1. Jacob, what did I miss? A lot of illuminating discussion. We had some invigorating conversations and challenging discussions about math. Everybody's been getting in on it and saying some really good stuff. So just make sure you add into that too. Peaked 5,000. You left off a 0. Yeah. Okay, now we know y and we know z. So now our last step is to figure out x. So let's work our way back to the beginning, where we started with either equation 1, equation 2, or equation 3. And we can choose either one of these and substitute in y, substitute in z, and solve for x. Probably equation 2 or equation 3 would be the easiest ones. Doesn't matter though. I'm going to have to scroll. I'm going to forget what these say. Negative x minus 4y plus 5z. So negative x plus 4y, but we know y is negative 1. Oh, sorry. I already messed it up. Right. Should be minus. Negative x minus 4y. Right, I'm doing equation 3 just because why not? So negative x minus 4y plus 5z, but we know z should be negative 4, equals negative 21. So all this is the third equation originally, but plugged in y, plugged in z. And we can solve. So that would be plus 4 minus 20 equals negative 21. 4 minus 20, negative 16. Either, I don't know, depending on how you do it, add x to both sides or add negative 16 to both sides, whatever. Okay, so add 16, negative 21 plus 16, negative 5. Not quite done, because I don't want to know what negative x equals. I want to know what x equals. So if negative x equals negative 5, multiply both sides by negative 1. So x equals positive 5. And then like we talked about last time, remember for our ending solution, the full answer, we want to write that as a coordinate x, y, z. So 5, -1, -4. And so that'll be that. What I have in that box there, that'll be what you type in like on the PFA answer. So parentheses, x value, comma, y value, comma, z value, parentheses, no spaces anywhere in there, just the numbers themselves. What a process. But we made it. Honestly, one of the hardest parts here is just keeping track of things. People get lost with all their work. So that's why I think it's smart to, even though it's not our final answers, do some type of labeling when you find each piece, the X, the Y, the Z, so that you don't, because you're going to need it. So you can come back to it. And then definitely do this with these two equations where you mark them in some way too. Okay, put a box around them, circle them, star them, highlight them, whatever, because I see a lot of time people know that they need to do something with these steps, but then lose the equations and forget to, oh, these are the things that I need to use later on. Okay. So there's our second example. All right, some bigger numbers and some, I don't know, a little bit more complicated work to do than the last example. But it's not any different from the elimination stuff you've been doing since, Algebra 1A. It's just more numbers now. When does this get hard? Good question. I don't know. It depends on what PFAs you've passed, Jacob. But I think you've done systems already. So nonlinear systems gets, again, more confusing. There's more things to keep track of. Matrices, when we start solving systems using matrices, that's when it'll definitely be frustrating. Not that it's not already frustrating, but it'll be a lot more details to mess up. All right. Let's dive into either one of these. Consider, so there's a certain situation that could happen depending on what the system is. So I don't know. We could do either one of these, or we can do both if we really want to, because you guys love math so much. But I'll go ahead. Let's just do this first one over here. So let's just start off assuming we're trying to solve this exactly how we normally would. So first off, I want to choose some variable to eliminate first. So I either want to eliminate A, eliminate B, eliminate C. It doesn't matter. You can choose whatever. So last time we eliminated the first variable, X. On the first example we ever did together, we eliminated Z. So for fun this time, I'm going to start by eliminating B. Okay, that middle variable, but that's just my choice from the start. Okay, so I'm looking at all of my coefficients. Oh, doesn't want to let me write here. I'm looking at all my coefficients for B. There's -3, +2, and -1. So first do some labeling. I'll first take a look at equation 2 and equation 3, just because they're right next to each other. And so for equation 2 and 3, the coefficients positive 2 and negative 1 for B. Then my goal should be that I have positive 2 and negative 2. That would be the easiest, the least common multiple between positive 2 and 1, or negative 1. So equation 2, I'm just going to leave exactly the same. And equation 3, I'm going to multiply by 2. So that I have 8a minus 2b plus 2c equals 50. This is great. This is what I want, that I have this positive 2 and negative 2. So I'll add these together. A plus 8a is 9a. 2b minus 2b, 0. Negative 3c plus 2c minus c. 25 plus 50, 75. And this is one of those steps where, okay, I got this new equation that only has 2 variables in it. I want to make sure I'm keeping track of that. Now I want to eliminate B again. So I did it with equation 2 and 3. So now I either want to choose equation 1 and 2 or equation 1 and 3. Right? Anything as long as it's not the same 2 equations you just did. Let's do 1 and 2. Or actually, I'm going to do 1 and 3. So for equations 1 and 3, if I'm looking at the B variable, the coefficients are negative 3 and negative 1. So my goal, I guess, would be 3 and negative 3. That would be the least common multiple. So I just need to think, what do I need to multiply here so that one of them has a coefficient of 3 and one of them has a coefficient of negative 3? Well, right now they're both negative, so I know I'll need to change that for one of them. It doesn't matter which. Let's say this first equation, I'm going to multiply by negative 1. So I take equation 1, everything gets multiplied by negative so that it changes sign. Okay, so right now that coefficient for B is positive 3. So I'm remembering, okay, I need to make sure that I make this next equation have a coefficient of negative 3. Well, the coefficient is already negative 1. So how do I get from negative 1 to 3? Well, I'll just multiply this by 3. So 4a times 3, 12a. Negative b times 3, negative 3b. C times 3 plus 3c. 25 times 3, 75. My goal has been reached. I have the positive 3 and the negative 3. Add the 2 equations together. Negative 3a plus 12a is 9a. 3b plus negative 3b is 0. Negative 4c plus 3c is negative c. 23 plus 75, 98. And again, let me star this, mark it, notify myself that this is important. So those two red equations, I'm just going to write them again, but together. It's just you. The video's still going. We're still good. For me, it shows it's still going. I don't know. Maybe refresh. All right. So with these two equations, now I want to eliminate A or eliminate C. Let's say eliminate A. So this should be pretty easy for us because we have 9A and 9A already. So I just need to make one of them negative. Let's make the second one negative. So negative 9A plus C equals negative 98. And the first equation, I'll just keep the same. 9A minus C equals 75. Add these together. 9A plus negative 9A, 0. Negative C plus C, 0. 75 plus negative 98, 0 equals negative 23. Yeah, exactly. So we've had situations like this before where we solve an equation and we get something like this where it's 0 equals negative 23 or 9 equals negative 12 or whatever. This is nonsense. 0 is not negative 23. All right, those are not the same numbers. Okay, so in this situation, this is what we call an inconsistent system. And what that means is if we have that situation where we're doing our solving and we get, two numbers on either side and they're not equal, but it says it's equal, no solution. All right, so this particular problem has no solution. All right, so just be careful of that. That's why I put up here at the top. This is an example. It's just a situation that could happen where we go through our solving, and even though we do everything right, we still end up with something weird, something that's total nonsense, like 0 equals negative 23. So that's impossible. At least in the universe that we live in, 0 and negative 23 are not the same numbers. So there is no solution. All right, so just be aware of that. That also could show up on the PFA. So if that is a situation, you literally just type in no solution. Right? And it says that on the PFA too. So you might be able to notice it from this step when we got these two equations. So we have the same thing, 9A minus C and 9A minus C, But then over here, that's too dark. But then over here, they both equaled two entirely different numbers. So if you got to here and recognized, oh, whenever it's the same two equations, but then they equal different numbers, we can already know from there that it's going to be no solution. Or you can keep going and do the full solving so that you get 0 equals whatever, and then determine. Either way. So I have another example up here on the right that it is a same type of deal. It will be no solution. I can go through and do that, or if you feel good about it, I can just leave you off, because otherwise that would be the last thing that I do today, right? I don't have any more problems to work through. I don't know. Any input from you guys? Can't we already tell from the 3b and the 3c? I'm not sure what you mean. Oh, in the second question. Can we already tell it's going to be inconsistent just by looking at these? Is that what you're saying? No, not quite, because these are still different. So we couldn't fully say. It might kind of alert your spidey sense that maybe I need to be on the lookout for it, but we wouldn't be able to just immediately look at this system and say that we know there's no solution just because the 3b and 3c are the same in both. Because the 4a and the negative 4a are still different, and then on the other side, the 9 and the negative 6 are still different. So there's too many things that are different to be able to say for sure that it would be inconsistent right now. Yeah, but it's a good intuition, right? Whenever you see a lot of stuff that is similar or the same, you can kind of not fully decide, okay, I know that this is going to be no solution or not, but it can alert you to at least be on the lookout for it. It's not a for sure thing, but potentially. Don't be surprised if it does turn out to be no solution. Good question, though. What would an unlimited number of solutions look like? Like an infinite number of solutions. That's a good question. If we had a system and same idea, or sort of similar idea, where we are doing our solving, but instead of getting, so like if I ended up with like 0 equals 12, that would be a no. What the heck? All right, then I would know that this is a no solution system. However, if I were solving and I got 0 equals 0, or 12 equals 12, or whatever, something that, while it is still just numbers, but it's true, right? 0 and 0 are the same number. 12 and 12 are the same number, but over here they're not. So in this case, I would get an infinite number of solutions. All right, good questions. Any others? Any two solution answers? No. Either there's three options. Either we're gonna have a system like this one, where we have one answer, -5, -5, 3. I mean, there's three parts of the point, but altogether that is one answer. Same thing here. We got one final answer. We can get no solution, or we could get infinite. So those are the three options. Nothing more, nothing less. We can get no solution, one solution, or infinitely many solutions. But anything between that, no go. Good question. I sent you a homework assignment Monday and today. Okay, so definitely use that to practice, to make sure that you're feeling comfortable with doing this. There's not a ton of questions on it, but I mean, I know that these are annoying and they kind of take a while. But so practice what you need. For as far as homework goes, I don't plan to collect it. And again, you're gonna have to know to do this stuff anyways. You're gonna still eventually have to do PFAs. Okay, once we finally start releasing those, I think probably next week, and gonna still have to do some type of performance task or project. So I don't know exactly. PFAs still are a thing. It wasn't talked about specifically in our meeting, other than the fact that we are still going to have to do them. I haven't heard the final plan on what the details of it are. So maybe. And then performance tasks, I don't know also what those will look like. I imagine my thought right now is it'll just be a very kind of stripped down performance task, where we, instead of a 4-page performance task, it'll just be a handful, like 2 to 4 questions that I'll make you do, and like send me pictures of your work, I guess. I don't know. That's kind of the thought right now, but we'll see. It's not